Hello everyone, this is Vikram and welcome to my channel. In this video, we'll see what is managed Kubernetes service and explore the managed Kubernetes service offering by DigitalOcean Cloud. We'll understand this by deploying Jenkins using persistent volumes and load balancer service type. So this DigitalOcean Cloud offers the default storage class and also makes it easier to provision a cloud load balancer for the service type of load balancer in Kubernetes services. So this is the overall content that is going to be covered in this video. So we'll understand what is managed Kubernetes service and why it is called managed. We'll understand the managed Kubernetes service offering by DigitalOcean by provisioning a 3-node Kubernetes cluster using the UI. We'll also see what are the default storage classes offered by DigitalOcean and how to use them to use persistent volumes. And we'll also understand how this load balancer service type works in DigitalOcean. We'll have some hands-on by deploying Jenkins on this Kubernetes cluster using the Jenkins Helm chart. In this, we are going to use the storage classes and load balancer service type. So I'm already logged into my DigitalOcean cloud. On the left hand side, you'll see this option called Kubernetes. So basically this is the managed Kubernetes service. So using this managed Kubernetes service, you can provision the Kubernetes cluster within minutes. And this is the starting price. So the starting price is $10 per month, which includes the control plane. So in managed Kubernetes service, you will not have access to the master node. That means the master node will be fully handled and managed by the cloud provider. In this case, it is DigitalOcean. So this control plane, which hosts your control plane components, that is the master node, will be fully handled by the DigitalOcean, and the master node and its components are fully included in this starting base price of $10. So we'll also have the pre-configured cluster networking with Cilium as the plugin. So Cilium also supports the networking policies. So by default, Kubernetes cluster that is provisioned through DigitalOcean supports the networking policies. We'll also get performance matrices, automatic upgrades directly by DigitalOcean. So we don't have to worry about automatically upgrading various cluster components. And it also has integrated load balancers and persistent volumes. Again, administration becomes easy because we don't have to provision the storage class and configure the load balancers. So in order to create the Kubernetes cluster, we'll create using this button. But before that, let's understand Kubernetes in detail. So we have various product documentation, some tutorials, some API docs over here. So if you click on this product docs, so here DigitalOcean provides a detailed documentation on how to use Kubernetes inside its platform. So we have the plans and pricing, we have basic droplets. So here the worker nodes can be a dedicated machine or it can be a shared machine. So we have basic droplets, which are regular or premium Intel or AMD, or we can also have CPU and memory optimized worker nodes. And we have reason availability as well. And coming to the features, so we can have Kubernetes API access through the DigitalOcean API, or we also have DigitalOcean CTL, which is DOCTL. So using kubectl or DOCTL, you'll be able to access the Kubernetes cluster. And DOKS, which is DigitalOcean Kubernetes service, conforms to the Cloud Native Computing Foundation's Kubernetes Software Conformance Certification Program. And we have worker nodes and node pool. So node pool is basically a collection of the worker nodes. And for the persistent data, we have block storage volumes, which are managed using DigitalOcean CSI plugin. And we also have inbuilt load balancing. So if you put any service type as load balancer, DigitalOcean is going to provision a cloud load balancer for you, and it is going to fetch you the load balancer IP. And we also have support for tags, VPC networks, and there are certain limitations as well. So a cluster can maximum have 512 nodes, and a single worker node can maximum have up to 110 pods. So this is the basic information that is given. And also there are certain known issues also. So we have to go through all of them. So if you are planning to use Kubernetes in our production environments, if you want to deploy your production workloads on Kubernetes in DigitalOcean. So this is the overall documentation. And also there is one more documentation that is provided. So that basically talks about running cloud native applications on DigitalOcean. So there, here they have discussed everything about microservices, how to deploy your microservices in the Kubernetes, So there is complete end-to-end documentation. So all the links that are needed to understand Kubernetes on the digital cloud are given in my readme document. So inside the Kubernetes cluster setup, there is a readme file called managed k8s on DigitalOcean, where I've given certain links to all the documentations, white papers, and all the relevant links that are needed to work with Kubernetes on DigitalOcean. And also I have the some test deployments and how to install Jenkins and the rest of the stuff. So everything is clearly documented. And this is the CSA DigitalOcean GitHub repository, where the CSA is container storage interface, that is CSA driver for DigitalOcean's block storage. So everything is already included in the control plane, so you don't have to configure anything at all. So now let's go to the cluster and see how to create the Kubernetes cluster. So all we have to do is we have to click on this create a Kubernetes cluster, and here you have to select the required Kubernetes version. So it is always recommended to use the latest version, which is 1.22. In case of DigitalOcean, I am selecting the default data center region, so VPC as default. Cluster capacity, so that so by default we have only 3 droplet limit on the account. So we can also request for the increase using this request increase button over here. And node pool name, so it's up to you, you can use any node pool. So I'm just using k8s -test. So using this node pool names, all the nodes inside your clusters are named accordingly. And for the machine type, that is the droplet. So basically all your worker nodes will be the droplet. So you can have basic nodes with shared CPU, or you can have premium Intel and premium AMD offerings, but I'm going to go with basic nodes only. And coming to the node plan, like what is the configuration needed for each node. So you can go for 1 GB, 2 GB nodes, or you can also go for 2.5 GB. Since I'm going to destroy this cluster after this demo, I'm going with 2.5 GB usable CPUs, the nodes, and the node count is 3, which is basically maximum. That's why this plus button is grayed out. So if you want to add another node pool, you can add it, but since we already reached the limit, you cannot create another node pool. Here there is an early availability, that is this is in the trial phase probably. So where you can have highly available control plane, where you'll have more than 2 master nodes running. And this is basically, it is early availability, so I don't want to check this, so I'll be not selecting this option. So monthly you'll be charged $60 per month, because there are 3 nodes and each node will take $20 per month. And in the finalize section, so I can use the cluster name. So cluster name, it's again it's up to us. So I'm just doing writing k8s -test project. So this cluster has to be a part of some projects, since I already have a project called first project. So I'm just placing this cluster in that project, or else you have to create your project here. And in the tags, I'm just leaving it like that and click on create cluster. So creating cluster will take some time. So these are the various steps involved. So first, creating a cluster is done. Then we have to see how to connect to this Kubernetes cluster. So if you want to install any patches, so these are all the step-by-step things that we need to do. So in the resources section, so these are the various resources, that is the node pool, a node pool with 3 instances or the worker nodes. Insights add-on. So in the add-on, so you'll have one-click apps. That means if you want to deploy Nginx Ingress controller, you don't have to manually do it. So instead you can just click on this install button. So DigitalOcean is going to automatically install the Ingress controller for you. So there are limited number of apps as of now. I'll go to the settings. So these are the various settings. So if you want to set the upgrade window, surge updates, destroy the cluster, so all the things are available over here. So I'll go to overview, and here so our cluster is provisioned. So if I just click on getting started, so there are 2 ways we can manage the cluster. So one is using the DigitalOcean CTL, which is DOCTL, and also manually using the kubeconfig. But in order to talk to the cluster, we'll be needing a configuration file, which is a kubeconfig file. So first I'm going to download this, and I'm going to put it in my downloads directory. And this is the kubectl command. So if you want to do kubectl get pods, So by default, kubectl is going to find the configuration file in the user's home directory under .cube folder, but here I have it in my downloads directory, so I have to give ---- kubeconfig and path to the downloaded kubeconfig file so that kubectl can talk to the correct Kubernetes cluster. So since I have downloaded, I'm clicking on continue. So I don't want to install anything, so I'm just clicking on skip. I don't want to install any add-ons, so I'm just clicking on skip again. So this is the overall cluster. So there are 6 vCPUs total, 12 GB of memory shared between all the three. Basically, this is for the complete cluster because there are 3 nodes in the cluster. And here you'll have the documents, API docs, tutorials, every other links from here. So you can get every information from here. So the first thing which I'm going to do is I'm going to connect to this cluster. So how do I connect to the cluster? So it is using the kubectl utility. So I already downloaded kubectl utility and I've already shown it in many videos as well. So I'll leave the link in the description. So if I just do kubectl, I'm going to get some output because kubectl is installed. Now if I just do kubectl get pods, so I'm not going to get any output because the kubeconfig file is not there. So the kubeconfig file is basically in my downloads directory. So there are 2 ways I can use this kubeconfig file. So first thing is I can use --kubeconfig and then use the kubeconfig file name and the rest of the commands. So using this I can talk to the cluster, but every time I have to use --kubeconfig for every command. So let's say that you wanted to get the node, so it's the same thing. So but the problem here is that I cannot use --kubeconfig file in each command. So that's why I wanted to set the environment variable called kubeconfig. So kubeconfig holds the list of paths separated by semicolon. So here I am just giving it one kubeconfig file, so which is k8s test project kubeconfig.yaml. So now kubeconfig environment variable is set. So now I don't have to use --kubeconfig again. So first thing which I wanted to do is I wanted to test the load balancer as a service type. So for this I have in my readme document. So here I am just running the nginx image with container port as 80 named as web server, and I'm going to expose this pod as a service type load balancer. So this is the first test we are going to do. So generally when you're running minikube on your local cluster, your load balancer IP, that is the external IP, will be in pending state forever. But in this case, let's see how DigitalOcean is going to provision the cloud load balancer for us. So our pod is created and also service type of load balancer is also created. So if I just do kubectl get pod and at the same time service, so it is get. So pod is in pending state, and if you see load balancer service type is also pending. So still pod is in pending state. So let's see why pod is in pending state by using describe. So successfully assigned to a particular node. Let's check the pod status again. So it is in the container creation state. Now the pod will be creating. Here the load balancer service type is in pending state. Now let's see where our load balancer service type is getting created. So if you go to the DigitalOcean cloud panel and if you go to this networking and then the load balances, so you can see that one of the load balancer is being provisioned. So here once it is provisioned, we are going to get the IP address. So here the load balancer is created and this is the public IP, but let's see whether it is shown in the kubectl get svc output or not. See here it is still in the pending state because it will take some time to reflect here. So let's wait till it gets reflected here. Now this is the external IP. So if you see, this is the same external IP that we had seen in the cloud load balancer. So this is it. And now if you want to test this deployment, so I can just enter this IP address. So you can see the output from the nginx pod. So let's see, after uninstalling, after deleting the pod and service, what happens to the cloud load balancer. So let us run both these delete commands. So that deletes the pod as well as the service. Service is deleted. So now if you go back to the DigitalOcean and look at the load balancer, so it is gone. So that means it got deleted. So when we deleted the service type. So this is about using the cloud load balancer. Now let's go back to the Kubernetes again and let me show the Kubernetes dashboard. So DigitalOcean hosts the Kubernetes dashboard directly from its UI. So you don't have to deploy the Kubernetes dashboard at all. So if you go to your Kubernetes cluster, so there is this option called Kubernetes dashboard. So if you click on it, the Kubernetes dashboard will be opened. So this is the Kubernetes dashboard. So basically we don't have any workloads other than the ones that are already running. So the pods deployments related to the cluster. Now let's see how to deploy Jenkins. So that needs the persistent volumes and the load balancer as a service type. So for this I'm going to use Artifact Hub. So here I have searched for Jenkins and this is the Jenkins Helm chart. So first we are going to see how to download this chart and untar it. So in order to do this, just click on this install button and first add the Helm repository using Helm repo add Jenkins CI, and this is the URL. So in my case, Helm CLI is already installed, and I've already shown it in many videos. So I'm just adding Helm repo add Jenkins CI and the URL to the chart. So this is already there. And now I wanted to download the chart, and that to the latest version. So I don't want to install it directly because I want to configure it first. So this is the chart actual name. So I'm just going to take this and use Helm pull name of the chart, and also this downloads as a tar file. But if you want to download and untar automatically, use --untar. So this is basically, it will download and it will untar it. So I'm just going to open that Jenkins. So if you do ls, you're going to find it in download section. So I'm just going to use code Jenkins to open this in the Jenkins, in the VS Code. And in the values.yaml file, I'll be making a lot of changes. So the first change is the load balancer service type, and also at the adding the storage class. So before adding the storage class, let's see what is the storage class that DigitalOcean is providing for us to provision the PVs. So just use kubectl get sc. So that is the short for storage class. So this is the default storage class name, so which is also called as a default. So this is the one which we have to use in the storage class section of our Helm chart. So we are going to look at search for storage class. So here we have to enter the storage class name, and at the same time I wanted to change the service type from cluster IP to the load balancer. So if you search for cluster IP, so this is the service type of cluster IP which has to be changed to the load balancer. So here Jenkins runs on port 8080, and the target port of the service should also be 8080. But if you put the service type as 8080, so we need to access the Jenkins on load balancer IP colon 8080. I don't want to use that extra 8080, so that's why incoming service port I'm changing it to 80 over here. And also Jenkins by default has CSRF CSRF protection, so this also we need to disable it. Later we'll enable it, because with CSRF enabled we'll not be able to log in into the Jenkins instance. So during the first run we have to disable it. So let's search for CSRF. So enable, I'm just making it as false. This is the one change that we need to do. So we have done everything, and if you check this Helm chart, basically this deploys Jenkins on Kubernetes, and it is also having the templates of various pods that access Jenkins agents. So if you want to explore more, you can take this chart and explore and deploy it later. So for now, these are the only changes that I wanted to do. Now let's deploy the Helm chart. using Helm install. The release name I'm giving it as Jenkins, and the chart is Jenkins. So this is actually the folder and this is the release name. Just click enter. Now this is going to deploy Jenkins controller as the stateful set with only one replica, and a PVC will be provisioned, and the service type of load balancer will also be provisioned. So here this is the Helm status. So admin is the default user, and if you want to get the password, so you can run this, but there is also another command which I have given in the readme file. So let's check the pod status. So kubectl get pod and service at the same time PVC, that is provision. So if you see persistent volume claim of Jenkins name is provision, status is bound, and this is the PVC volume capacity of 8 GB, and this is the storage class which you have configured in the Helm chart, and the age is 25 seconds. And the load balancer service type external IP is pending, and even your pod is pending because during the first run it is downloading some plugins. Now if you go to the DigitalOcean and then go to the networking section, if you go to the load balancer, you will see that one more load balancer will be provisioned for the Jenkins service type. And if you go to the Kubernetes dashboard, you can also see the current status of your deployments. So here the stateful set Jenkins is running. So if you go to the stateful sets, you can see that Jenkins stateful set is up and running, and this is the services Jenkins service type. It is orange because external IP is not shown here. So there are persistent volume claims, one claim by Jenkins, storage class, the default storage class by DigitalOcean, and this is the provisioner. And if you want to see the events in your cluster, so you can see the various events. Let's go to the services and wait till the load balancer IP is provisioned. So here our load balancer is provisioned. So our load balancer is provisioned and we got the IP here. If you see the Kubernetes dashboard, it might take some time to show the external IP. But once it shows, so directly that will be an hyperlink. So if you click on it, directly your UI will be opened. So let's wait for some time till the dashboard shows. See here, this is the external IP, which is the load balancer IP, and colon 80 because we changed the service entry port to 80. So if you simply click on it, so it will open in the other tab. And for the username, we know that it is admin. For the password, so in the Helm status already certain commands are given, so we can run these commands kubectl exec and all. But I have one more command, so which is kubectl get secret. The secret name is Jenkins. So why secret name is Jenkins is, so if I just use kubectl get secret, so Jenkins creates a secret with the login credentials, and the name of the secret is Jenkins itself. So here kubectl get secret in the namespace default. So if you have deployed Jenkins in any other namespace, use the appropriate namespace. And using Go templating, I am just iterating through all the data in that secret. So if you describe that secret using kubectl describe secret Jenkins, so there are actually two values. So one is holding admin user and the other is using holding the admin password. So it will iterate both the values and it is going to decode both of them. So I'm just going to copy the command, and if you enter, so you're going to get the admin username and the password. So this is the password, the username is admin. Yeah, so this is the Jenkins landing page. So if you click on new item and just use a test job name and click on freestyle project, so it is going to throw this error, no valid cron was included in the request. So in order to resolve this, I'm just going to go back to the dashboard, click on manage Jenkins, click on global security, and then just use this enable proxy compatibility and click on save. Just refresh this page once. So even, yeah, so this is now saved. Now go to the dashboard, click on new item, test, freestyle. Okay. I'm going to not restrict it anywhere. So this job, I wanted to run it in the same node where Jenkins pod is running. And in the build step, execute shell. I'm going to, so it's quite slow. Execute shell. So I'm going to just run hostname. Apply. Save. Then build your job. So here it is saying pending, waiting for next available executor, because currently there are no available executor. The reason is, if you go to manage Jenkins and click on manage nodes and clouds, and if you see the built-in node, and in the configure section the number of executors are 0, so that means in your master pod no jobs will run. Basically you have to use Jenkins pod as the executors or the agents to build your jobs. Since I have not configured any agents, so I am going to give number of executors as 2 in the built-in node, and click on save. Go to your dashboard again. Now there are 2 idle executor because we have set the number of executors as 2. If you see, this particular test job is now successful because it is able to find a executor, and the console output says the so I think so an agent has been provisioned, so I think it is internally configured in the Helm chart. So if you see, a pod has been provisioned and then your job is run inside that pod. Basically this pod configuration is there in your Helm charts values.yaml file, if you see clearly. So that means even if you don't increase the number of executors in the master node, it is going to work. I'm going to go to the master dashboard again, click on the job and try to click on build now again. Let's see where it builds this time. If you see the second output, so this time it built on the same node, it didn't provision any Kubernetes pod. So in order to verify it, let's go back to the dashboard again, click on manage Jenkins, manage nodes and clouds. In the built-in node, configure, put the number of executors to 0, so that means no job will run here. And then if you go to the nodes, configure clouds, so here Kubernetes Kubernetes is already configured as a cloud, so that means, so you don't have to do anything in the configure cloud. So here all the details are already filled, so the service type and the Jenkins agent pod label, so everything is already configured, so that's why it is able to provision a pod for you. So in order to prove whether a pod is provisioned or not, so let's do kubectl get pod and use -w2 to watch the cluster. So here only one pod is there. Now let's go to this job again and click on build now. At the same time, go to the terminal and see a new pod will be provisioned or not. So all I wanted to see is, yeah, so if you see, a pod is provisioned, container got started, it is in the running state. So once the job is done, your pod is going to be deleted automatically by the Jenkins. So let's see when it's get deleted. So it is terminating now. So it will be terminated and deleted. So this is about installing Jenkins on DigitalOcean cloud. And in order to delete this particular cluster, you can go to the settings and click on destroy over here, or else you can also click on this actions and click on destroy the cluster. So it is, so it says, so once you click on destroy, it is saying destroy the load balancers, yes, destroy the PVCs, yes, and click on just enter the cluster name. So in case if you have uninstalled your deployment or the Helm release, so these will be automatically deleted and you may not get this option. So all you have to do is you have to use Helm uninstall and Jenkins to to uninstall your Jenkins release. So in my case, I am directly proceeding with the deleting the cluster without Helm uninstall. So that's why it is asking me whether the load balancer should be deleted and volume should be deleted or not. Give the name of your Kubernetes cluster and click on destroy. So now your entire Kubernetes cluster will be destroyed, and it is destroyed. So that's it about running Kubernetes on DigitalOcean and how to consume load balancers and storage classes, which are by default provided by the DigitalOcean cloud. So this is not about the DigitalOcean cloud. Even in all the cloud providers, they provide the cloud load balancers and the storage classes. So but here in the digital clouds, the instances are much cheaper, and provisioning the cluster is very easy. Thank you, and I'll see you in the next one.